Ja, super. Dann wir schalten den Wagen machen.
Okay, so you can manage the topics actually. And you know, I just had a brief introduction and you can tell me what to say.
Yeah.
What you like.
Yeah.
I just want to show the comparison somehow between XMSP and csound by picking up an example of implementing the serial framework for composition and using frequency modulation to be implemented in both environments. This is the simple example of frequency modulation and instruments that we have the opcode in csound and XMSP.
Okay.
And the instrument. And it's the description for the framework of serialism that uses serial code to be used in different aspects, pitch, harmonicity or timbre, and velocity. And it will go into details of the design and implementation using score and timeline object in XMSP, and also the instruments and different opcodes related to the implement. Throughout, we can know the similarity or comparison. So, if you do not like, you said that Maximus is good and we can go on.
Yeah, if you don't mind.
Do you like Maximus?
Yes.
Or serialism or both? Or
Both.
So I go on.
I'm more in XMSP than
more in Maximus. Okay, and about the Maximus, the version that I used is 4.6. Because in 5 there is no timeline object, as you can see here.
This global transport.
Exactly. So this was the reason that I used 4.6. And I have the patches here that can be run on PC, but I don't know if you it's wrong, but I think you can see it here. So I think you know about frequency. I go actually in more speed if you like. You can tell me just to slow down.
Yeah.
Anywhere. I think you know about frequency modulation, of course.
Yeah.
Okay.
Do you want me to tell something?
No.
Go on. And maybe you know about the output frequency modulation is csound.
This is this is a simple frequency modulation.
Of course, the simple version by chowning.
I'm not so good in marks, but I see. So dotted line is the audio signal, yeah.
In Maximus,
yeah.
Exactly. This is
okay.
the
So it's clear, okay?
Both, yeah.
Yeah.
Sure. And I can skip the frequency modulation. Both in Max and csound. In Max is okay.
Yeah.
Max is okay. csound is a little tricky for me, but when I see them I understand csound.
So this is the instrument 1 that uses FM.
Yeah.
And these are the parameters: duration, key, velocity, harmonicity, modulation index, and for each note you can have attack percent on this
So
percent.
is that harmonicity?
Harmonicity is the thing that I think Chan proposed.
Just so the frequency deviation. Okay.
Exactly, the harmonicity ratio is modulator frequency divided by carrier frequency. That if we have some integers, the timbre of the voice would be harmonic or inharmonic. We have some odd numbers. So, can I go on or stay here? Instrument 1, that's just we can add some attack percent and release percent to have some kind of envelope volume number for each note. And these are the other parameters that are used for FM. And we have pitch and velocity and vibration. Okay, one. So here is about serial, you can tone. So this is a series,
Yeah.
and in 12-tone music we use it just for pitch, and series is extended to other aspects. Should I focus more on here? I can focus.
Geht schon.
But
Das ist qualitativ ganz
Syrian, I know a lot about Syrian music. So
der Weite.
this is,
Okay.
of course, it is pleasing for me to, if anybody talks about Syrian music, and I love it.
Nur
But,
den Bildschirm nehmen.
actually, if you're gonna just
Die Leute
describe
jetzt wichtig sind.
what is raw or what is the difference between surrealism
So eine
and
Bank gefahren ist, wir können das einfach
12-tone,
verstehen.
of course, it is quite clear.
Okay, but I say if you think I should speed it up.
Das Mikrofon wahrscheinlich auch gesagt, das könnte zu weit weg sein.
For my size,
Okay.
Stimmt, wo es hin steppt durch.
So I use something in between.
Ja, wir machen das besser.
Yeah.
Okay, das besser für
You know,
Das nächste.
in 12-tone music, there's a rule that we just have to pick up a number
weiß nicht,
between
vielleicht kann man
0 and 11,
Da
and
in
we
den
have to
Schrank
repeat
schließen,
notes until
den
we have
einfach
the
so hinstellen.
exact
Da
roll. For example, starting from C as the note in an octave, we could have, for example, this roll 0 and 6, 10, and the sequencing the pitches, if we assume that the reference pitch is, for example, 48, would be 48, and then we have 1, it would be 49, and then we have 6, it would be 48 plus 6.
This is a mini pictures?
Exactly.
Oh, okay.
So the roll would be C, C sharp, G sharp,
Yeah, that's it.
and in serialism we extend this aspect to other parameters. For example, velocity, timbre, articulation. So we have to use the same roll for the other aspects. For example, using this roll, we have velocity, and we should have a mapping for these digits to the exact velocity. For example, if we assume that velocity is something between 0 and 127, we can have this formula that is multiplied by 127 divided by 11.
So we scale it.
Exactly.
In the velocity.
Exactly. So the same rule would be
Excuse me, but why do you divide it on 11?
because we have 12 numbers. You know, the maximum velocity regarding 0 to 11 would be 11. Okay, 0 is 0 velocity, and 11 should be 127.
So there's
So,
okay.
so this is why we divide it by 11, because if we use row element as 11, it would be 127, which is the maximum velocity. We scale it as a linear basis. 0 would be 0, and 11 would be 127. Maybe we can use different formula, for example, multiply by 3 plus 80. We miss some velocities.
Exponentials.
Ah.
Yeah.
And we can have another mapping for timbre. If we use frequency modulation having harmonicity, we can have a table having 12 different elements, each of which producing a harmonicity having a different tempo. So for velocity, we can have a linear formula. For timbre, for harmonicity, we can have a table, predefined table.
I have a photo
Photo.
of this.
I can give you the presentation,
Ah,
and I think it's here. If you're right now.
I think one of the main differences between 12-tone music and serialism is as well that you don't need a row with 12 elements. You can take a row with 4 or 5 or 27 elements in serialism.
Exactly. And that is in different aspects, other than pitch.
Yeah.
Generally, you can use a 4-element row, 2-element row, or 12.
so sound workshop folder, yeah.
Yes. There are different folders, one for Max, one for csound, and the presentation and PDF is in the parent folder.
anything?
So as you know, we have different transformation types: retrograde, inversion,
Yeah,
and
inversion retrograde.
inversion retrograde, exactly, and with transposition.
Yeah.
All of them can do with transposition. So here, for example, we can use P1, and the resulting row would be this original row plus 1. This. And we can have retrograde without transposition. This is 0, 10, and it is. So, okay, regarding the score and the composition, we can have two different events. We can use each of these rows for transformations for each of the aspects. We can have a command that we want to use P1 for pitches, we want R0 for velocity, and I0 for timbre. Okay. So the first one would be something like restart with 3 different parameters, P1, R0, and I0. So as I said, it says that we should have this row for generating pitch, which would result into this, as we have here, and velocity using this kind of transposition. So in each step we would have these velocities, and harmonicity using I0. So you would have this row, this row, that would be this one. So this is the first event we start with these 3. The next event will be next node. I mean, for each tick we can have a node.
Excuse me for interruption. Did you get all 3 rows? I mean, pitch row, velocity row, and harmonicity row from 1 row?
Yes,
Yeah.
exactly.
Okay. Okay.
We can change it, but this is the simple version.
Yeah, it's the serial conception to get everything from 1 mode.
Yes.
Okay.
So whenever we have a next node, we can have 3 different aspects together generating a node. So we traverse a series that we define. The first next node event would have 1 for pitch, 10 for velocity, and 0 for harmonicity. The next node event will have 2 as pitch, 8 as velocity, and 11 as harmonicity. And we can have another restart for changing the rows or new using new rows for piece. Okay. For example, this is the csound score. We can assume that whenever we have a -1 in duration, we are talking about restarts, and we specify 3 transformations for 3 aspects. So we have here 2 restart events, one for instrument 1, because we can have the polyphonic instrument. One for instrument 1 and another for instrument 2. For instrument 1 we have a restart command for P0. This is actually an in code. We have 0 for P, original, 1 for inversion, 2 for retrograde, and 3 for retrograde. So here would be P0 for pitch, I0 for velocity, and R3 for harmonicity for instrument 1. For instrument 2 we have retrograde inversion with 2 as transposition for pitch, R0 for velocity, and IR3 for harmonicity. This is 2 restart commands for 2 different instruments. And after that, we can have next node commands to each instrument. For instrument 1, at time 1, for duration 3, we have a next node command with attack and release here. And at the same time, actually 1, we have another next node for the second instrument with another attack and release. So this would be our scope going on. And here is a similar timeline for max MSP. What we have here, csound. these are two commands because in this max we have a timeline, and underneath we have an action that gets some commands, just like some events that are going to some instruments. These are two different commands. The restart, exactly like this section, and these are two different commands for next nodes, just like this section, and the numbers are the same. So this is the implementation of actually instrument two. Instrument one was a frequency modulation instrument, just used for the sound engine, sound synthesis, but this instrument is instrument two that we send the commands for serialism, restart and next node. So as I mentioned, we have actually protocol here. Whenever we face P3 as -1, we know and we're sure that we have a restart command. And when we have a positive in P3, we know that this is a next node command. This is how we differentiate between these two events. And in MaxMSP, it's actually simpler because we have different commands. Restart command here and next nodes here. But in sound, in csound, we can just know using this P3. So this is restart here and in MaxMSP. Okay, should I do something about this translation in Max, or can go on? It's okay.
Okay.
So we can use another encoding for transformation to get simpler. We can, for example, multiply transformation type. I mean, for original, inverse, retrograde, or inverse retrograde, multiplied by 100 and plus transposition. So by just having one number, we can know the transformation. I mean, transformation is transformation type and transposition. Together. For example, 101 would be P1, and 202 would be I2. So when getting the restart command, we should call 3 other restart outputs: restart pitch, velocity, and harmonicity based on this transformation types. Okay, just please tell me how much do you like to go into details of this specific implementation? Maybe it would be good to focus on something else rather than explaining this specific one. What were you like? Is there?
Just to know more about how you implement the theory in MaxMSP. First, do you type the main series somewhere, or do you have it in the timeline?
Exactly. Actually, the best choice is that you can have it in the timeline, because you can have a score that anytime you like, you can have a new role.
And how do you cope with it in csound? Do you have a F table with stereo, or?
Yes. You have a table. It's actually in the remaining section.
Sorry.
Okay. So this is next note. Here is the csound code, the left and the right. This is the max MSP patch. So, just like restart, that we should have 3 different outputs for pitch, velocity, and harmonicity. In next notes, we have 3 different outputs for next pitch, next velocity, and next harmonicity. Just the responsibility of next node, just like restart, is that it should call 3 different aspects. This is what you're talking about. Okay. In the left side, we have the row. Right now, it's inside the patch, but simply it can be in the score.
Yeah.
you can add a command, just a command to the action, and pass this table to action. And so this is the role for composition, and this is the harmonicity table that specifies the predefined table for generating timbre. And this is the table in the csound for role. That in max you can fill it just like this. Okay, and we need two different tables. One for keeping the current transformation for each aspect, and another one for keeping the index, because in each next node the index should advance in this way or maybe in reverse order. So we need this kind of indexes to keep the current index for each parameter. This is the table in csound, and this is the table format in Maximus. Okay. And so we had restart and 3 different restarts, and next node and 3 different next pitch velocity and harmonicities. And this is the simple implementation of different restarts for pitch velocity and harmonicity just by this reusable opcode restart row. Because we can have an abstraction that we just want an opcode that advance an index and just return to us the next row element defined in the row. And after that, just a mapping is needed. For example, for pitch, we can, I don't know, add it by 48 as the default reference pitch. Or in velocity, we can have the linear formula, and in harmonicity, we can have the predefined table. But restart row can be used for all of them, manipulating the tables and using indexes. So for restart pitch and restart velocity and restart harmonicity, all we can have restart row, which we see in the next slide. And also for next pitch, we have the same. We have next row elements, a reusable opcode. Should I go on, or any specific points up to now?
Yeah.
Okay. So this is next pitch, this is next velocity, and this is next harmonicity. They are actually similar to each other except the mapping. They all call next row elements, and just there are also some mappings here. This is the formula for velocity, and this uses the table for the actually collection in Maximus for table in csound for harmonicities. And this is restart row that just advances indexes. And the point is that only we should know if it is a prime or inverse. In these 2 cases, we have to advance the index to the right. Or if it is a retrograde or retrograde inverse, we have to reverse the index. This is the functionality of restart row in csound. And this is the last opcode, next row element, that should just have an access to the row table, and it knows the indexes for each aspect, uses that using 3 different tables for pitch transformation, velocity transformation, and harmonicity transformation, and extracts the next element in the row. And this is the Maximus batch. Okay. So, anything specific that I have to focus more on? Any suggestions you may have, a better implementation or anything?
Oh, in the moment.
Of course, as for me, this is a nice idea as opposed to have a graphical interpretation of a serial matrix.
Yes.
Like typical 12-tone matrix,
Yes,
or like
exactly.
Boolean matrix in structures, the ordinary matrix, but some cells
Yes.
I'm circle, that means that's a parallel matrix series. I suppose in Max, I'm not Max programmer, but I suppose in Max it could be quite easy to perform this such kind of user interface.
Yes, for user interfaces,
But
Max is.
I suppose this is not about any interfaces, it's just the idea realized in
Yes.
Max.
But yes, exactly. In the final slides, it's somehow a comparison between Max MSP and csound, and the point
Yeah.
that you said is exactly true, I think. Because in Max MSP, although we have, I don't know, FLTK or widgets in csound, but in Max MSP, the user interface is somehow attached to the language itself, and you can have user interface, I believe, more easily. Or maybe because from the scratch you are involved in user interface in Max MSP, it will be easier for many developers to handle user interface rather than csound that first you learn what is code, and after that you have to learn something to have user interface. But exactly, you can have the matrix for actually rows, I don't know, I's here, P's here, this, and in the user interfaces. But the framework that you saw automatically actually could generate these different kinds. There is no need to see them, because you just have to say that I want I2 for velocity, and automatically it will generate. And you do not need to see the table and write the notes. It automatically generates the notes for you.
I would be very interested in listening to the different projects.
Yeah, of course. Yes.
Could you please
Of course. And I would like to know your actually idea and belief about Max MSP and csound. What do you think about them? Which one do you prefer to use, or which one do you think is simpler in which conditions?
Well, as for me, Max is better.
Better.
Maybe
Generally.
because of visual part.
Yes.
I mean, really, I play much live electronics, and so Max MSP I would prefer Max MSP because I can just implement my different controllers and my live playing stuff, and
Yes.
you can compose the instruments in Max MSP.
But what if logic gets too complicated? I mean, I believe that when you want to connect wires and have a user interface so soon, Max is great.
Yeah.
But what if you have a complicated logic? Is it too simple? I don't know. Sometimes I think
It's
that
not-
maybe
yeah.
coding is better. Because
Sometimes it's you have to do some strange things and go the other way around because you have much copy and paste stuff,
yes,
and so it's very complicated to copy all those things to just generate the same thing again and again.
yeah.
So I would prefer to use csound at that
Yes,
moment.
exactly.
Because you can just type the formula and then generate always the same with one formula.
You know, something that I really hate in Max is the order of the precedence, you know, from right to left. Because sometimes it drives you crazy to debug it, why
Yeah.
this does not work after this one. And
My worst problem is
Yeah.
working in Max is debugging.
debugging, yes.
Versus the sound, you know that if you get an error, you could, as for me, it could be found quite fast.
Mm.
But in Max, sometimes the problem is that you just need to reconnect.
Yeah.
And you have like 25 subpatches and search in every one of them. Yeah, but it's not that bad in Max 5.
Mm.
I think in Max 4.6 it's some strange things with wires and that you just have to reconnect them to get it working.
Yes, Max
It's not
5
that bad
is
in Max
more
5.
beautiful
Yeah.
as well.
Yeah.
And you have some helpers for debugging.
Mm.
That's better. Okay.
So, music?
So, right now there are just 4 notes for the
Okay.
actually in both environments.
Interesting.
Okay, disconnected. Speak right now.
If the sound on the stereo, we have cable here.
So there we go. Thank you very much.
Oh,
Maybe we should. But maybe we should try to disconnect the power. Could I?
Yes, right. It is the. Great.
play
A
something?
little bit better.
Yeah.
So
No, I
the
think
start.
the sound is not.
Is it your sound? Or
No, maybe we can hear it from
Isn't
laptop.
it distorted?
Yes, it is. This is the sound.
okay.
So this is the simplest score that causes 4 notes.
Mm.
Just to compare between. This is neutral. Nice. Two instruments.
Yeah, really.
Could you please
Sounded
render?
very different, I think.
Yes, in details, yes.
Could you please render the csound file in audio and show it oscillogram and the spectrogram?
Right now,
If you please.
I think I do not have installed the,
Oh,
yes, the required to show the spectrogram here.
yeah.
If you have,
I have.
Ah.
You could just render it and then I could use my.
and there is another longer version.
modulation multiplier. The maximum is how much time?
Maximum of the duration, I think, no limit.
Okay.
You can change it here. And you can anything you want.
Yeah. That sounds great. Yeah. I like frequency modulation.
Yes.
It's
Really?
nice sounds.
Yeah, nice.
Really
It's
cool.
a nice idea to connect tempers of frequency modulation to serial technique.
Yeah. And the fact was that it was total serial.
Yes.
All the commands
Yeah.
serial.
Did you try to implement this thing with csound in Max?
The piece you mean? No.
Not the piece, but like the rows and the serialism, because that could solve just this problem with copying and pasting all the things and using this really complicated timeline object. So if you could use the from csound, this whole implementation of the series, and then play in Max with it. So you
I
could-
exactly don't get what you mean. In Max, we have the same approach, but in Max 4.6 we have timeline. Do you mean about time point in Max 5, or what?
So just use this math stuff to create instruments to play with. Because this is you can compose with this like you did in csound, but you could use this sound generator, which is founded on the series and made with frequency modulation to create an instrument to play with.
You know, we have it here. I don't know, just a point about it. This is the score, and we have an instrument.
Yeah. I'm not talking about instruments like you understand instrument in csound.
You mean general?
Yeah, really an instrument to play with and to create different sounds, but not randomly, but
Yes.
based on this scene.
Exactly. You mean generally, apart from this
Yeah.
specific. Yes. And did you work with time point in Max 5?
No.
I actually don't know why they removed this timeline object. I like that.
Yeah.
This is
I
a
like
score, but in Max 5 we do not have this. I don't know why.
You have this global transport, but this is more based like a metron or something. You can easily change metric things in the music, but you don't have really.
Yes, it's more graphical and you can see the partiture.
Yeah.
But with time points you have to just put. Okay. So here. Was it H-O, huh? Remember the syntax? H-O and the name of the wave. What was it?
You want to render?
Yeah,
But you may press render.
and the name?
But you have to set some path, I suppose.
Yes, maybe it's.
They already set.
Here. It's finished.
Okay.
So. like me to, you want to connect to the screen? Or not?
I have it. I like to hear and see sound. It's quite interesting. So the attack differs too. The attack and
yeah, of course.
Yes. Here are the values. This. If you like, I can render the second sample, which was done.
that doesn't help.
But if you could render, can you just render this maximum speed example?
To compare.
That would be, yeah,
Yes.
very interesting. Maybe you can load it in the same modesty file. Just have a direct comparison.
You mean
Of the maximum speed file and the
Ah.
CSOund file.
sure. It should be a bit greater, yeah.
Yeah.
Because they are really have a great distance, and this one aligned components.
Yeah, I wonder what this 7.15 kilotone is.
It's less than 500, and this is the zip 1000 on the
Yeah.
500
Yeah.
hertz.
Yeah, yeah.
Right, so it's the exact peak. That. Yeah, that.
It's very high.
Side band.
Yeah, maybe.
Yeah.
Yeah.
$800. 8,000.
Yeah.
Okay, you're waiting for the render in max, huh?
Yeah.
Yes.
So we're gonna compare.
Mm-hmm.
Okay. You can even try to sum it inverse. I mean, we can
The
enroll
new.
one file and mix them,
Yeah.
find difference.
Wave or I think the color of the sound differs because one of the reasons is the modulator of these two sound is different.
Yeah.
Because of the table in csound is something else, a cycle in Maximus.
Yeah.
It is one of the reasons.
I often heard about the better sound quality of csound comparison to Maximus Speed, but I didn't really hear.
Ah.
Find a scroll bar on the scroll like
Which version is it?
of this tip.
Yeah. I think the beta version is.
This is 1.3.13 beta.
Yeah.
Those are the one.
Yeah.
And right.
So, I think we can use the step record,
Yeah.
And you can see that if you do not want to use this, I want to edit in maximum speed and you go on with me. For rendering.
Yeah.
Yeah, sure.
Don't you want the screen now?
No, no.
Oh, okay. Okay, it will be the step record. Let us hear this. Simple. You know, because
And that
if
is-
I do this, it connects to the box.
Yeah, yeah, I know this. You should do it at the very last point.
Yeah.
And I don't like this rendering stuff in maximum speed because it's really complicated when
Yes,
you work just like with different duck
Instrument.
objects, or
exactly.
because you have one duck at sub patcher 3 and one duck at
Yes,
main
so we
patcher.
have to connect all the instruments here to the separate record.
Yeah, really.
Yeah.
It's kind of hard.
This could be a comparison between these two. In csound it's too easy, just
Yeah.
push render and
Yeah. But that would be a very nice function of maximum speed. To have this render object from csound
Yes.
and just render everything
Yes.
what goes
Yes.
in the output object.
Yes. Why doesn't?
Yeah, I don't know. Can't be that complicated.
I think a record can search. Is it? All this.
Just put a toggle on.
This is two.
Yeah. But as a record it has default 2 channels.
One of the worst problems, Max, is that you have a difficult patch. The connections are so difficult to be read visually
Yeah.
compared to.
And this stuff is very, very bad thing.
Yeah.
Because imagine this thing with 8 channels, or every time I do things with 8 channels, I have one patcher
Many
with
wires.
wires and wires and wires.
But poly objects could be used, but again, it
Yeah,
has
but
some different
you have to put them
complexities.
at some time. You have to put them in this duck object,
Oh,
and even a poly object has to wire at this moment.
I have a clave-knob modular, and they have an ability, clave-knob modular.
Yeah.
They have shake cables options.
Yeah.
You could deform them. I mean,
Yeah.
cables like shift them.
exactly, cables. Yeah.
Yeah.
You can do that in order. Just, I think this is Control J.
what's your second?
Where you just sort the wires like you did.
Sort you mean?
Yeah.
You mean segmented patch codes, or just sorts, select and sort together.
Yeah.
Control J.
Control J. I think it's Control J. But then you have to-
Which menu option?
Oh,
Something that I like and I mostly use is segmented patch codes like this,
Yeah.
not just. Okay.
but
I think
doesn't
it's-
matter.
Is it enough? I think open the name of the file and just shortcut.
With just those two instruments.
Yes, because we have just two instruments.
Yeah,
It's a sample.
Yeah.
Yes.
Don't mess with my eye,
Yes, you are right.
Okay.
Does it need a stop or something to end the recording?
Yeah, I used to do a toggle on the
Yes.
record object, because then you have start and stop.
Yes. I think it's finished
Yeah.
now.
Yeah.
We have the name of the file and
Just
first.
yeah, start.
Oh, that's peak.
Yeah.
Okay.
We have to start with open again, I think. Because
Yes, of course. Just to make sure.
Just write.
yeah,
So.
it really doesn't sound this allergens or
You'll see.
it's shorter, isn't it? The second.
The times could be different because in the timeline
Okay.
there is not some exact. You have to actually just pay more attention
Yeah,
to
okay.
just the timing of the
Okay.
system. Yes.
Mm.
It was somehow the timing is somehow, but the sound should be. If we ignore the cycle and
Yeah.
it should be similar. This is the point that time point is better because you type the exact time.
Yeah.
But in the timeline, you have to pay attention that
Like a
you
real
have to
storm.
see a vertical line. Where are you and where do you put the event?
Yeah. It's not that precise.
We can check. For example, when is this event? It's hard. We can compare to csound.
I think we'll see.
Yes, it is 1 23 in the out.
I think the second one is too short.
Which one?
Starts.
This
Would you give me a
short, you mean duration?
Yeah.
I think duration is the same.
Yeah. And maybe it starts to run.
This is 3 seconds. And here, 3 seconds. Yes, maybe the start is different. Okay,
Just find. Just need to raise it for a while. This is a second. This is a second with a half. That means that we need to raise it approximately. Yeah.
Okay.
So the envelopes are quite close. Ah no.
Oh no. It must be velocity then. This shape here.
Yeah.
This is different.
Oh, but the spectrums are quite close.
Mm.
This have this on the ribs.
Yes, exactly the duration, the start, as you said, the start.
Of course, I thought there's a. The sound should be quite bright. You see, to compare the amplitude of harmonics, but here we see
Yeah.
some more lines, but actually they should sound quite close to each other. There's harmonics here, harmonics there.
The score of
Yeah, this is very, very precision precise analysis. It, like it's so
we can do the thing that you said, combine together. Reverse.
it should, if to make it, it should be a sample line. We need to feed it sample by sample.
Yeah. Nice suggestion.
I think the next thing sounds like a little hard.
We also
Can you
put
play?
this-
The csound thing is with soft attacks and like more rendered sound. It's
we also put
opinion.
we also put heavily zoom to sound. Structure quite close.
Yeah.
And it's scroll. Zoom out for a while. A little
Face
difference.
is inverted. somehow.
Yeah. The shape a little different. This is more narrow.
Is it because of the sine wave used as a modulator? I think it's
Maybe, yeah.
You can invert.
Sounds very similar.
So it's the signals are pressed.
Yeah.
nice. It was nice to compare.
Yes.
Yeah, we could analyze the average. This is the spectrum of the first, the average spectrum. The problem with audacity, you cannot how to say it? You cannot see several spectrums layered on each other. So I cannot layer announce. This is compared to Adobe Audition. It's quite sad. So I need to close and to make a new.
This is the second one.
Yeah. Nothing special. Yeah.
Yeah, interesting. Is there a possibility to create different actions in the timeline object automatically? Or you could use the role to generate
Generate the events.
Yeah.
A piece that is automatically generated as
Yeah,
serial.
maybe. Yeah. And you just have to type the first row.
Yeah. I don't have any idea. Can it be?
No, because you have to just really
Yes, nice.
type the. But maybe you could use a collection object.
Maybe we can generate the source, I mean, for the timeline. That would be possible, yes.
Yeah.
Some kind of source generation. Yes.
It would be interesting because you can. There's this really much work to
Yes.
set the things.
What the result? What would be? Maybe you don't like that.
Yeah, maybe. Yeah, but
Yes, well,
it's worth a try.
that's nice examples. Nice to meet you. A piece that is serial even in the score and the generation of the events.
In the last thought. That's realism.
You're analyzing. I mean, are you analyzing again something?
No.
And show us first.
Typical Apple. Open.
Yeah.
Okay, thank you very, very much.
Thank you.
It was so
Yeah.
nice for me.
Yeah.
Learned many things. Thank you. So if you want to suggest anything,
Drinking coffee.
that's choice. Thanks.
Yeah, thank you.
Don't forget your flashcard.
May your name, please?
David. August.
David Bogus.
Yeah.
Okay, nice. Email or something? I know you.
Yes,
Of course, I have your contact.
And if you
This is
could
my
send
address.
me this presentation, it was would be very nice.
And right here. Is there your email in the site? csound conference? I think yes.
Yeah. I suppose it should be in a paper. If you click on
Yes.
the paper PDF.
Sure, I will.
Is it yours or?
No,
Maybe
but you can
I
use.
write it. Yeah.
It's simpler that you write now.
You forget the key. Just a joke. Because I begin to write on a score.
I think it's
Yeah. The worst key ever. I cannot read and then just begin to count. Okay, this is C, it means so this is this. So I hate this key. But I like the. It is easy to.
just name it like.
So, should be there. Half of me is Polish, so it's Polish
really?
surname, I guess it's.
Yeah, okay.
How you call this sign?
At
At, no, I mean, they have some slang name for it. Because in Russia we call it dog.
Oh, really?
Yeah, because this is a dog with ears.
Okay, yeah.
Curled down.
No, we
like
don't have a name.
This is a dog.
Yeah.
It's like a nose, ear, and the body, and the tail, so we call it dog.
Okay.
Even on government,
Okay.
even on government level, they call Leper Gazinski dog. And
Yeah, really.
really.
Okay. And then you can type dog to protect yourself from
From spam, yeah.
yeah, exactly. Okay, and mine is here.
If you would write me an email because I have nothing with me,
I can
I'm
send
not
you.
really prepared. Oh, yes. Ah, the old-fashioned way. Okay, thank you.
Okay, I can send you or right.
I will find you mail on the side.
Weißt du, wie der ausgeht? Wie der Beamer ausgeht? Haben wir hier eine Fernbedienung?
And the
Achso.
Is it yours?
No.
Nichts mit
So it's not.
Nee?
Are you finished?
Yes, yes, thank you. When is the next one?
Well, there was supposed to be one. Well, now we're late. It was supposed to be that we go from 11:30 to 12:30, 15-minute break, and then 12:45 to 1:45. And the time now is 12:50 or 12:55.
Ah, okay.
Did you want to? Were you going to repeat yours?
No, I think
twice. Or,
I'm supposed to, but I think maybe there would be no need. I don't know.
yeah, I don't know. I was.
I don't know if it is required.
Yeah. Okay. Then.
Is it your break?
Yeah, that's for the video camera, I think. Oh no, what is it?
A bomb?
It's a bomb! Somewhere.
Yeah,
Oh,
it's
it's
in the
a,
project.
yeah.
The conference are too small to be bombed.
Yeah, exactly. And, but that's we could be very American and say, the smaller you are, the more likely it is you'll be bombed, because that's exactly what they want to do. All this small town American thing is.
Okay.
Yeah, but that's exactly the problem. That's what they want. The terrorists, they want to get us in our small town. That's what we never expect. If you want to be scared, there's always something to be scared of.